risk because it's supposed to be those who are exposed over the total number of those at risk. But I don't know. I'm just trying to think what I was thinking, to voice out what I was thinking.
Okay, thank you, Cyrus. Maybe you can consult the notes. We have the notes.
I think, Chris,
Yes, yes.
Before even we consult, I
Yes.
can read a statement here which summarizes or wraps what relative risk is all about.
Yes, yes.
We say relative risk, which is the same as risk ratio, compares the risk of a healthy event. Could it be a disease, injury, risk factor, or death among one group with the risk among another group? So it is you compare the risk of a health event, maybe a disease or injury or something, among one group with the risk among another group. So you're only dealing with one group versus the other, and has ratios now.
Okay. So Cyrus, does that make sense now? Yes, Cyrus?
Yeah, yes. No. What I was trying to say, but I think because it's for instance, it's A over A plus B to find the risk, the incident.
Oh, so you are talking about the addition, not
yes. I was trying to say it's 96. Divided by 96 plus 256. That's what I was trying to think, but I don't know. Like to find the risk for less than 20,000 household income. But I don't know. I was trying to confirm what I was trying to think.
Okay.
But it's okay.
So
I remember this is a relative risk, and then there is what we call the odds ratio. Relative risk, the way we go about it has always been different.
Okay, so this is different from yes, Lois, please, you can weigh in.
Okay, I'm also thinking the same way Cyrus was saying, because I feel like what we have calculated is the odds ratio. And for the relative risk, it's the risk of exposed over risk of unexposed. And the risk is calculated as the total number of cases over the total number of people who were not cases at the beginning. So it's 256 plus 96.
Okay.
Yes, the total people who did not have the disease at that time. Then they were followed up. So what was the risk? So the people who are exposed, who had the disease over the total number of the people.
Okay, so let me go back to, sorry for that. I was trying to look for the note, but we can deliberate on that. So you are saying that we say our calculation will be 96 plus 256, right? If I got you right.
96 over 256 plus 96.
So it is plus, not multiplication.
Yes.
So that now we say 0.375 plus 0.067. Sindio?
Okay.
Yeah, because the calculation is 96 over 256 plus 36 over 540, right?
Yes.
Okay, so let me do the
okay. Wait. 96 over 256 plus.
Yeah, plus.
No. So the risk, the relative risk here would be 96 over 256, 96 plus 256 divided by 36 over 540 plus 36.
Repeat again. 96 plus 256.
96 over 256 plus 96 over 36 divided by 36 plus 540.
Okay, nimepotea. Someone
yenye imeandikwa kwa chat actually.
Okay. So now this one is better because now we will say so it is thank you for that. So we'll say A plus B divided by C over C plus D. This is easier because now I can be able to calculate and everyone can be able to calculate based on that. So that now we will have 96 in bracket over the bracket. Sorry for that. 96 plus 256 over or divided by C, which is 36 in bracket over bracket 36 again plus 540. If we all agree on that, we can now proceed and calculate and do the calculation. Now we see if we got the same answer. Any objection to that formula, please?
No, I have no objection.
Yeah.
No objection. I think we're in the right direction.
Okay, perfect. Thank you. So we can proceed and do the calculation so that we ensure that we all got the same answer. It is a tragedy for 10 of us to get one wrong answer. So you can calculate and share what we got. I think here we will apply body mass if I'm not wrong.
Yes.
Yes.
Sasa pole.
Okay.
Siko na nini?
Nini yo?
Messages. Siko ingia WhatsApp during the day.
Okay. See, it's okay. We have just started actually. We are in number 1A. We are just doing the calculations.
Okay, all right.
Yeah.
That's fine.
Yeah, we will share with you.
Sir.
Anyone with who has got the answer? Yes, Iras.
Yes, sorry, my mic was on. I didn't switch it off. So it is 4.3636. So it's 4.364 into 3 decimal places are found.
So you're saying it's 4?
4.364.
4.364. So anyone with a similar answer to?
I also got the same answer.
The same too.
Okay. I'm trying to finish up here. So 0.273 divided by 0.130. Where did I get this? 36 over 576. Yeah, I think this is where I got from. 0.0625. Then you say 0.273 divided by 0.0625. Yeah. So the answer is 4.368. So that is for number A. I think we Anyone else who has got maybe a different answer? Good, we can proceed because of time. So that is the answer to number 1. Then we go to, so you decide to use PCR for the leftover stool samples to assess the accuracy of the cat's stool test in the diagnosis of helminthiasis for your master's thesis. You find that cat's test was 100% specific for helminthiasis, but only 80% sensitive for the same. So we talked about specificity and sensitivity. So sensitivity is the ability of tests to correctly pick the positive result, and the specificity is the ability of a test to pick correctly the negative test. So calculate the corrected relative risk based on the new information obtained from your study. That is, the RR, or the relative risk, which would have been obtained and your colleague study used PCR for diagnosis of helminthiasis instead of cats. So seems we need to come up with another 2x2 kind of table. Ama? Hii kitu tulifunzwa lini? I can't seem to remember. I can remember relative risk, but okay. Sikusikia hiyo kitu. But now how do we come up with the answer for part B? Anyone? So you want to calculate the corrected risk, relative risk. So because now we are told for the specificity, meaning this part of the negative, the negative is 100%. So I think this one will remain the same the way it is, but this one we'll have to apply the 80% sensitivity. So I don't know, because PCR is 100%, if I'm not wrong, in terms of both specificity and sensitivity. It's a PCR. It's able to pick the DNA of the microorganism. And I have an idea how to go about this. Let me even come up with a document that you can actually, let me just use the Excel. I like Excel, so that you can use that to draw the table. Ideas sasa zikuje. We have Excel. Or we don't need a 2x2 table for this.
I think we will adjust what we were given based on those percentages of 100% and 80%. That is my thinking.
Yeah, so let them use ideas, but ideas zikuje.
Mi naona tufuate notes za lecture 7 za misclassification huko chini. Tutapata idea.
Good. Let me share them, so we can keep that for. Let me look for those notes and share. So you have seen the 7, different. Good. Here you go. So lecture 7 is here. Is it starting? Okay, so tumesema ni kwa miscalculation. So hapa. So this one looks like a odds ratio unless ni chini. Still odds ratio. Odds ratio. Is odds ratio similar to relative risk?
No.
Okay. So hizi notes zilikuwa, unajua mimi sikumbuki tukifunza kitu kama hii.
Odds ratio na relative risk are two different things.
Wenye mna attending physical class hii maneno tulifunza lini ya kuadjust after umepewa ama ni ile part ya kufunza, so ni kama aliamua kuset cut on that area yenye alisema hatafunza because of time. Lois, nani ako na idea hii kitu tusonge? Acha hata niirudishe ndio people can
Irudishe.
Acha niirudishe ndio tufikirie iko hapo. Where is it? Good. Someone want to speak? Yeah. Yes, Esther? Ama ni Lois? Yes, Esther.
Mko question?
Tuko question no, question 1B. So,
okay.
So we have calculated for question 1A na tukasema answer ni 4.364, the relative risk for that number 1A. Then tukaambiwa the number 1 we have calculated using the yes. Yes, Esther. Proceed. We can't hear you. Esther ni kama kuna shinda network, you can't hear you well. But basically what I was saying, we managed to calculate for number 1. Now we are told the answers or the data that we have was arrived at using Catocat. Then we have the PCR. PCR is a reference test. So kinda the ideal that you should use when you want to diagnose helminth infection. So we are told that you decide, that was your colleague. Now you decide to use his own data, now to using the PCR, which is the reference. Then you use the leftover stool, meaning the sample size will remain the same. So we need to have the same number of the total. I don't know what is the total, but you can calculate to see the total. Now, we are told the accuracy for Catocat tests in the diagnosis of helminth infection for your master's thesis. Now, you are told, you find that Catocat test was 100 specific, meaning it was able to pick all the negatives. Because we say specificity is ability of a test to pick the correct negative result. But now when it comes to sensitivity, picking the positive result, it is 80%. My assumption is because PCR is the reference, should be having both 100% specificity and 100% sensitivity. Now we want to play around with these figures to meet what? 100% specificity and 100% sensitivity. That is my understanding for this. And that is why I was... Yes, please.
Please,
Yes, Ruben.
I tend to go about it this way.
The
moment we are told there were 80% sensitivity, it means that some of the positives were false, right?
Yes.
There were false positives.
True.
So it means some of the and we are told the PCR proved 100% specificity,
Yes.
meaning it was able to capture all the negatives. So I tend to think that we are going to go by 80% of the 96 and the 36, and once we get the 80% of 96, that the result is what we put there, and the extras, what once we get 80% of 96, we capture the result there, and then the excess goes to the other side because it was a false positive, or else it was supposed to be negative. We take it, we go and add the remaining to 256. And the same will happen to those who were earning greater than 20,000, that is for the 36 and for 540. Then we'll be able to know to what extent the relative risk changed. I think that is my take.
Thank you. Thank you. I tend to agree with you. Anyone else with maybe a different or supporting Ruben? Kindly let us participate. We save on time. Do we agree with that calculation? Maybe for those who have not understood. So what Ruben is saying, you see this column here of the positives. Because we are told, I can see someone has agree with Ruben. Yeah, that is good. So you see this column here is for positive, and we are told it is 80%, meaning there were around 20% patient or people who are picked wrongly. So to do, we say 0.8 or 80% of 96. We say, so that is 0.8 times 96. Let me see. So that should be 76.8. And because we are dealing with the human being, I think we cannot have a decimal, so we can have it as 77. Then we say 96 minus 77 is 19. So this 19 will go to 256. So we will have 77 in table, no, part A of the table, we will have 77. Then part B, we'll say 256 plus the 19 that we have identified as false positive. Then we do the same for those who are earning below above 20,000. So I want to see if in the chat. Haya, Sabina, are you able to speak? You can explain this point well.
I'm saying
yes,
because it is 80% sensitive, it means only 20% were misclassified.
Yes.
So we just do 80% of 96, 80% of 36, 80% of everything. We don't subtract anything. Sasa ingekuwa 20%, tungefanya 20% of 96, ndio tunge subtract. But so because it is 80%, we're not subtracting anything.
Okay, so we say 0.8 times, no, 80% times, okay, 80% of 96, tumepata ni 77. Then tuseme 80% of 36, tumepata ni 29. Should we do the same for the other part, for the negative?
For the negative,
yeah.
For the negative, the no column.
Yes.
The specificity was 100%, so it was everything was captured.
Yeah. So we are not. We will leave. Now, where will we take the 19? And that is why I think that is what Sabina is trying to cater for by saying we need to take 80% of everything. I don't know. Ruben,
if I may ask Sabina, I'm also learning, but I would like to.
Yeah, we are all learning.
Yeah,
Wait, Ruben, wait. I agree with you because the specificity was 100%. So
yeah.
we won't do 80% of the no's. The specificity was 100%.
Yes.
Yeah.
Because I was just about to ask you, because these samples, all of them were subjected to a test. And then remember the test captured everything, and then it captured the sensitivity of 80%, and it means since the specificity was 100%, it means it took the 20% to the other side. Everything was captured on the other side.
Yeah, I agree with you.
Okay, so my question is to both Ruben and Sabina. So what happened to 17 that we have removed as so there is 17 for column for that row number 3, and we have also removed 7 because it was 96. We have 77 now. It was 7. We have 29. What happens to that? The 2. What happens to 24?
We are saying, I'm saying that's my thinking.
Yes.
We cannot do away with them because they were captured. They were captured by the test. So unless there is another way approaches to this kind of mathematics, we will not get results. They are false positive and just ignore them. How now? And that's my thinking.
Yeah. So we need to know how to fix these 24. Where do we fix them? And remember, this one it's 100% specificity.
Chris.
Yes, please.
So okay, what I'm thinking is we come up with another 4x4, 2x2 tables with the adjusted figures. So hapo kwa 96 umesema itakuwa 77.
Yes.
Yeah. And hapo kwa 36 itakuwa ngapi?
Itakuwa 29.
Ikuwe 29, alafu ingine ibaki to 56. Hii ingine ilikuwa 540.
Yeah, ilikuwa 540.
Alafu to calculate the new RR.
Okay. So you have still not answered my question. Where do we take the 24 that we have removed?
After the 80%. Okay, I don't know because, for example, Lek ame subtract.
Okay, so what you can do, we can go back. Umesema ni which whatever lecture?
Lecture 7.
Lecture 7. Benson, you want to weigh in?
The total is not. Chris.
Yes.
I've been just listening.
Okay. Do you want to?
No. Yeah, I want to contribute kidogo.
Okay.
Now, I think you are right. But since you are calculating the RR after the corrected,
do
we need the negatives?
No, we are saying, trying to. We are saying that now that we have removed 17, or we have identified there were 17 false positives. On this part, let me go back to. So on this part, we have calculated the 80% because now we are told the cuts is 80%.
So 80% of 96.
Yes, 80% of 96 tukapata ni 77, meaning there were 17 positives. Then to calculate 80% of 36 tukapata they are 29, meaning there were 7 false positives. So that's what we were saying. Should we add them on this other side? So that now we have 256 plus 17, 540 plus 7. So that now that becomes our new 2x2 table.
Okay.
I can see Esther is supporting. We had the negative. lecture 7 hii mahali hapa. Yes, you see. Wacha tutafute yenye si ya control. Sorry for that. So we have now this part here. If we end 20% exposure miscalculation in cases and 30% in control, so you subtract 10. So we have subtracted that 17. Then yeah. So these are the positives, the exposure, the positive. Then minus percent, then add huko kwingine. Add 10. Yeah, I think that we should do the same. Yeah.
Chris.
Yes.
I'm for the opinion hatufai ku add because tutakuwa tuna affect the 100% specificity on the other side. Tuki-add hizo negatives zenye, tuki-add hizi misclassifications za the cases wenye walikuwa na hizo elements.
So where do we take the 24?
So hizo the 24, okay, in my opinion, zitatusaidia because hii RR ya kwanza ni ya the crude nini data. Hii ya pili ni the adjusted data. Zitatusaidia kucomment on the misclassification yenye iko hapo question C.
Okay.
Unaona hii kwa hii example ya lake, hii cases.
Yes.
Cases kulikuwa na 20% misclassification. Sasa ndio mfanya 20% of hizo cases akapata ni 10. Sasa amesubtract kwa nini? Amesubtract hiyo misclassification hiyo 20%. Alafu pia kwa controls kulikuwa na misclassification ya 30%. Hapa kwetu okay, hiyo side mwingine ni 100%.
Yeah, I tend
Okay,
to agree. No, I tend to agree with you, but I'm looking at it in the perspective of a lab tech. So if you are lab tech and you do a test and then it gives you positive, do you repeat the test again? Because now if it has given you a positive, you don't now this is where we
you don't confirm.
Chris, I tend to contribute. While I'm checking or looking at the screen where you are, I can see exposure, cases, controls, and where we have 50, we happen to subtract 10, we get 40. And where we have 50, we subtract 10, and on the other side, we add 10, right? Even for controls. We subtract 6, and on the other side, we add 6. So I don't think whether it is in any way different from our case. And my thinking is, I don't think whether we can exclude those figures.
Yeah, because if you see, if you look at this, it is
100% we are talking about, the 100% we are talking about specificity. It's not that the numbers should remain the way they are. The issue is the test managed to capture all the negative cases. And when it was objected to the positives, the test said of the positives, there were some which were false positive and they were taken to the other side to constitute to be part of the negatives, right?
Yeah. So yeah, so let's hear from someone else because I'm thinking the same. When you look at this miscalculation for the lecturer, the sample size was 100, and at the end of it, it was still 100. It was 100 this end, and after miscalculation was corrected, it remained 100. So I'm trying to look at the 24 that we want to exclude. Where do we take them? Someone else want to contribute, please?
Chris.
Yes, please.
This 24, they are in the side of negative.
Yes.
So lazima uzirudishe ile side ziko positive after doing PCR. So ideally the negative will be 96 plus 24, that is 120.
Let me share this. Let me share this first so that we agree. So you are saying?
Just share first.
So we will say
You see,
we will say 96 minus 96 minus 7. No, it will be 77 here.
77.
Yeah, because it is 80%.
No, Chris. You see, this 96 the 80%, isn't it? I tend to differ with you. 96 is equivalent to 80%. What about 100%? That is what we're looking for, the 20%.
Yes.
Isn't it?
Yes, even as one of us here has commented.
Let me try and draw the 2 by 2 table, so that we see we can be able to get the same sample size. So here we were saying we will put 77, then here we'll put 29, then here we'll say 256 plus 17, then hapa tukasema 29.
17 or 19?
Should be 19, right?
Okay.
Let me see. It's in 96 minus 77.
19, eh?
96 minus 77. Yeah, should be 19, sorry. So should be 19. 19, then here we will have 7. So that now the total will be 256 plus 256 plus 19, 275. And hapa chini itakuwa 36. So that now when we say 96, 96 plus 36 plus 256 plus ile ingine ilikuwa not 29, it was 540. Na mniambie 540, so it will be 547. 547. So plus 540 should be, sample size was 928. Poteza kalamu wapi? 928. So if we calculate using the current figure, do we still get the 928? Let's see. Because that was the sample. Because alichukua zile stool samples zote zenye huyu mwingine alikuwa ametumia. Then we say 77 plus 29 plus 275 plus 547 is 928. So our sample size still remains. What has changed is we have just corrected the miscalculation. Tuko sawa? Hello?
Is there? Chris.
Yes, please.
You see, when this the researcher was trying to do these corrections, he did not even. This guy used the remnants of the sample.
Yes.
Had already been tested. So he was only trying to test the sensitivity and specificity. He used very few samples for each. He did not. He only wanted to see whether the test was correct, the diagnosis. So he used just a few. He decided to subject them to PCR and a few samples, right? Because he was going to the remnants. He did not go for every sample. I don't think whether he tested every sample.
So what does that mean?
But whether I doubt whether he tested every sample again.
But we are not we are told the
leftovers. To use PCR in the leftovers 2 samples to assess the accuracy of the cut-off is to test the diagnosis of Elmides for your master. You find that okay, it's okay. Maybe he used all.
Yeah, because we are not told whether he used all or
maybe he used all of them.
Yeah. Okay, so we agree that this will be our new 2 by 2, so that now we are able to calculate. So we all agree that this will be our 2 by 2, our new 2 by 2 table. Sindio? Please tuongee, time imesonga sana pia.
I think iko namna hiyo, unless we still have time tomorrow. We can, in case we go and do some more research on matters calculating risk ratio and find to the contrary, we can always report.
Okay, so we can work with this. Then we will have to, kila mtu ataenda alafu ataangalia kama inakubaliana na vile vitu tumesema. Assignment no cut 3. Let me save this one here, then we proceed. So let's calculate the relative risk. So tulisema
Soma charts za Esther.
kuna chart ingine. No, I already did mpaka nikafika kwa hii yako ya I agree with your sample. There is 20% differential miscalculation in the positive outcomes. So what does that mean? We cannot do, we all, I ran them mpaka nikafika kwa hii yako ya I agree with you for the sake of sample size, and we have ensured that our sample size still remains as 929. Good. So so should we proceed and do now the relative risk?
Yes.
Which is now A over, let me see what is in the chart. Okay, good. So A over bracket A plus B over C over bracket C plus D. So tutasema 77, I hope we are following. 77 plus 275. I tend to think the answer will remain the same. Over C, which is 29, bracket 29 plus 47. Sawa mpaka hapo. So we proceed. Saidiana kuna over hapa. Not calculation, not multiplication. Then we say, so it will be 77 plus 275. I hope we are following. Start alikuwa ashafanya, but now we need to 17, 10. Is it 17? No, we are subtracting 19. 19 tuna subtract kila mahali.
Hello, Chris.
Yes.
77.
Yes, Benson, 77. Sini 80% of 96. So 0.8 times 96.
Iko namna hiyo.
Ama? 0.8.
Yeah, it was 76 point something, which is
basically. Esther, are you able to speak? Please, you can enlighten us. Maybe kuna mahali tunapotea. Because kwa calculation yenye Star ameshare kwa group naona ametumia 19 all through. Hello. Kama hii swali ndio hatuelewi. Like, kama kuna kitu if you have something to say you can, and you are not able to speak, you can type in the chat ndio tusaidiane hapa, ni kama tunakwama. Tumepata hii ya kwanza vizuri, relative risk. Now we are told you decide to use PCR for the leftover stool samples that was used by someone else akitumia CATOCAT. Now you decide to use PCR. Then after you use PCR, which is a reference test, you realize that this CATOCAT was 100% specific. So it is able to pick the negatives. However, sensitivity on picking positive, it was 80%, meaning there was some 20% of samples that were picked wrongly. So they were false positive. Now you calculate, we are told to calculate the corrected relative risk based on how on the new information obtained from your study. That is the relative risk, which would have been obtained and your colleagues then used PCR for the diagnosis instead of CATOCATs. And that is why we have done for this column of yes, which is positive, tukasema, we say 80% of 96, we get the we get to know how many were picked wrongly, which is 19. And we did the same 80% for 36 tukaona they were picked 7 wrongly. So they were supposed to be negative, but they were picked as positive. Then tukasema hizo 7. So we come this sign so that we ensure that the sample size remain the same. We add the 19 this signed here, called this column B, not column B, but yeah, row B or column B, whatever it is. Then we add 7 here. I want to see. Oh, yeah. I think now you're in the same page. Okay, thank you. So let's proceed. You can see we all agree on that. So we were trying to calculate this thing here. So tukasema that will say 77 plus 275. It will be 77. I hope someone else is calculating so that we don't get a. We'll say 77 over 352 over what is it? It is 29 plus 547. So it is 29 over 603. We say 77 over 352 is equal to, if I'm not wrong, if someone else is trying to over 29 over 603. Zero point 0.048. So the final answer will be 0.12, no, 219 over 0.048. So the new relative risk is 4 points. Looks like it is the same. Ile ingine ilikuwa ngapi? No, there was the other one was 4.368. So this one is 4.56, actually 3. Sijui kama kila mtu amepata hiyo ama mimi ndio nimecalculate.
4.48.
4.48,
which is just the same as 4.5.
Oh, okay. So we all agree that is the answer for number 1B, so that we proceed. Okay. If you have kindly, if you have a different opinion, let us know, so that is the essence of having a group discussion. Just contribute so that we. Now, what type of bias did your colleague study have, and what type of miscalculation did it lead to? So thank you, Esther. So what type of bias did your colleagues study have, and what type of miscalculation classification did it lead to? So hii miscalculation ni gani? So hapa ndio point iko. I think should be, yeah, this should be hapa ndio maneno iko. So this effect of differential miscalculation biases the odds ratio towards the null value of 1, meaning it deflates the association. Are we talking about the same thing, or nani ako na answer, so that we go to number 2? Time imesonga mbaya sana. Anyone? Kindly. Yes, please. Esther.
I think it's a differential classification.
Now imagine we can't hear you. Sijui network iko na shinda leo. Are you able to type in the chat? Anyone else with a different opinion, so that we can proceed because of time? Kindly use the chat. You can unmute and speak. All answers are right. It is an adult class. You just have to defend your answer and give us the correct one. But there is no wrong answer. As we wait for Esther to type that, we can be proceeding to question number 2. Is try to see if we can be able to do a little bit of it. Then, yeah. So let me take you through question number 2. Consider the following abstract risk factors for cervical. Yeah, let me see what Esther typed. So differential miscalculation, because of the degree of miscalculation, differs in both cases and non-cases. Differential miscalculation, because the degree of miscalculation differs in both cases and non-cases. So that is the type of bias. Okay. Since that is the only answer we have for now, we can work with that. So I want to read through this abstract quickly. So the authors assessed risk factors for cervical intraepithelial. No, let me start with risk factors for cervical intraepithelial neoplasia in Southwestern American Indian women. So the authors assessed risk factors for CIN among Southwestern American Indian women using case control methods. Cases were New Mexico American Indian women with biopsy proven grade 1, they were 90. Then grade 2, they were 70. Grade 3 were 42 cervical lesions, diagnosed between November 1994 and October 1997. Controls were American Indian women from the same Indian Health Service clinics with normal cervical epithelium, and they were 326. All subjects underwent interviews and the laboratory evaluations. Interviews focused on history of sexual transmitted diseases and sexual behavior, that is the number of partners. Laboratory assays included PCR-based tests for cervical human papilloma infection, tests for gonorrhea and chlamydia, wet mount, and serological assays for antibodies to Treponema pallidum, herpes simplex virus, and hepatitis B and C viruses. In multiple logistic regression analysis, the strongest risk factor for CIN among American Indian women were any human papilloma infection, odds ratio of 5.8 with 95% confidence interval. Whatever that is, I think lower the upper limit. So low income was also under an odds ratio of 3.3 with 95% confidence interval. And history of any sexually transmitted disease and 20%. Same confidence interval. So unlike previous research, this study found no strong association between CIN and sexual behavior, that is the number of partners, after adjustment of other factors associated with CIN. Substantively note, human papilloma virus is a causal agent of CIN. So what study design was used by this study? So which type of case control was this? Do we go back to read through the abstract again? So they had this I think this was done between 1994 and they followed from 97 to 1994. So they went to the records. Which type of case control study is this? Someone, please. Matusome then. So we have different types of case control studies. So we have, let me go to, so we have, so did you use secondary study base or primary study base? Thank you, Esther, for that, for trying to elaborate your answer further. We will consider those as well. But I want us to know if this was it a primary study base or was it secondary study base? We have hospital controls. Then we have nested case control study. Hello, kuna mtu anataka contribute hata kwa chat? Kama tuachane na hiyo swali basi, imekuwa ngumu. So let me read at B of the question tuone kama kuna it will bring some inspiration. So the authors felt it was notable that unlike previous research, this study found no strong association between CIN and sexual activity as measured by the number of sexual partners. Assuming this was not because of chance, selection bias or measurement bias, can you explain why there was no association found? So we are trying to look for a reason. This actually in your ile swali rahisi kabisa ni vile you are not able to pick this part, but this part of part number B can be explained using the different. So tumeambiwa toa chance, toa selection bias, toa measurement bias. Can it be a real association? No. How do we can we say that the sexual activity and CIN, that there is no association, there is no true association between the two? That can be one explanation. Number two,
Great.
yes, Ruben. Saidia hapa. Benson, yes. Please.
Okay, why do you say that there is not association? Sorry.
Oh, Richard.
Yes.
Kumbe uko area. Mbona nini yako inasoma Benson?
Niko na Benson.
Oh, uko na Benson. Okay. I'm saying, could be that whatever the study found was not wrong. As in, I'm trying to use the language of a researcher, but could be there is no association between CIN and sexual activity. That could be a true picture. True or false?
Okay, hello.
Yes, Richard.
You are repeating the same thing. Explain why there was no association found.
Yeah, so that is why I'm saying, you remember the six release zenye mwalimu anapenda kuonyeshana sana, hizi ndio naongelea mimi. I'm trying to break it down into this. But you can weigh in, eh? You can contribute, no problem.
Confounding.
So confounding, yeah. I was trying to bring it in this angle, because we have been told there is no chance, there is no random error, there is no bias, especially selection and information bias. So we are left with these others. Ndio nilikuwa najaribu kuona kama inaweza inginia. So umesema confounding. How do you explain confounding in that case?
There could be some confounders which maybe were not noticed.
Should I repeat the yes?
Chris, where are we? I went off here a little bit. Where are we?
Okay, we are. Let me just read this question again so that we can be on the same page. Let me go back to the abstract. So I'll start from the risk factors for CIN in Southwestern American Indian women. So the authors assessed risk factors for CIN among Southwestern American Indian women using case control methods. Cases were New Mexico American Indian women with biopsy that are proven grade 1, they were 190, grade 2, they were 70, and grade 3 were 42. Survival conditions diagnosed between November 1994 to October 1997. It's a period of 3 years. Controls were American Indian women from the same Indian Health Service clinics with now the normal cervical epithelium. They were 326. So all subjects underwent interviews and laboratory evaluation. Interviews focused on history of STIs and sexual behavior, that is, the number of partners. Laboratory assays included PCR-based tests for cervical cancer, human papillomavirus infection. Number 2, test for gonorrhea and chlamydia, wet mounts, and serology assays for antibodies to Treponema pallidum, herpes simplex virus, and hepatitis B and C viruses. In multiple logistic regression analysis, the strong risk factors for CIN among American Indian women were any human papilloma infection, that is odds ratio of 5.8. Low income was also another factor with odds ratio of 3.3. And history of any sexually transmitted infection was odds ratio of 2. Unlike now the previous researches that were done, this study found no strong association between CIN and sexual behavior, meaning the number of partners did not correlate with development of CIN. So that after adjustment of other factors associated with CIN, so probably there were confounders and they were removed, or maybe something like that. So substantive note, human papilloma virus is a causal agent for CIN. Now, what study design was used by this study? That is question number 1. So, yes, please.
Case control study design.
Case control, we know it's a case, we already told it's a case control, but which type of case control? Because we have different, we have the nested dealing in into aji. Which type of case control study? And that is why I was in this lecture too, trying to look if we have different. So case courts design. We have we talked about the primary. Yeah, I can see someone else. So we can say mixed methods because we had case control studies and use of interviews. So Esther is suggesting that you can call it a mixed method. So we end case control studies, use of interviews and lab evaluations. So anyone else with a different or supporting the answer? Okay, I don't even have a problem with that. We can proceed to question number 2. This one we can answer maybe by tomorrow. Now, part B. The author felt it was notable that unlike previous research, this study found no strong association between CIN and sexual activities as measured by the number of sexual partners. Assuming this was not because of chance, selection bias, or measurement bias, can you explain why no association was found? So that is where we were, Ruben. We were trying to answer part B. Part 1, we can go think through it. We can revisit the notes, but let's think of part B.
Okay.
So Ruben was trying to explain, not Ruben, but Richard was trying to explain confounders. So Ruben, have you got an explanation to that?
I'm still thinking about it.
Okay, Richard? So apart from confounder, which we will, Richard will take us through, which other reason do we have this kind of scenario? And that is why I was saying, what if it is a true picture? That there is no correlation between sexual partners and development of CIN. Could be wrong. Can we talk about recall bias? Because maybe someone can forget. Can someone forget about the number of sexual partners they have had? And what about yes, I'm told people can forget their sexual part, how many, and especially
I will forget. I will forget.
Yeah, so you can have one as recall bias because you are doing interview to see if someone can really tell you the number of partners that they have had in their life. Probably someone who is a sex worker doesn't even remember the number of partners they have had in one day. So could be. We can talk about probably recall bias. Do we agree with that? Ruben, do you feel recall bias can be an explanation?
I think the key explanation there will be confounding.
Confounder. So I'm trying to think, how do we bring out the confounder? Because I know confounder will support a positive finding, not a negative finding, right? If maybe there was an association between the number of sexual partners and development of CIN, then we could think of confounder. But this one is a negative finding, that there was no association. So how does confounder play part in that? Remember, we are told the main culprit is human papilloma virus. And remember also, human papilloma virus is sexually transmitted.
Yeah. Okay, I agree with that. But maybe other, my thinking is, maybe there are some other factors which are responsible for this neoplasia, which came to play, and such that it was not necessarily because of human papillomavirus. There were other factors which contributed to this CIN, and that were the confounders. Thank you.
So we can talk about
Chris.
confound. Yes, Richard.
Okay. You see, if the question is, the author felt that it was notable that unlike previous research, this study found no strong association between CIN and sexual activity as a measured by numbers of sexual partners syndrome. Assuming this was not because of chance selection bias and measurement bias, can you explain why there is no association? So lack of association could be due to confounding variable. Maybe which were not adequately controlled in the analysis stage. Senior. Analysis when they were doing the analysis.
Okay. So we can have that point, then we can try and defend it. Then Esther. So, yes, Ben Nani Richard.
Maybe risk factors for HPV infection.
Yes.
Example, social economic factors, e.g.,
yes.
Access to healthcare.
Yeah, and that is why we are told. Yeah, we are told there is the low income played a part with the odds ratio of 3.3. This part. So low income is part of socioeconomic status.
Yes. So we can explain it from there.
from that angle, on using this angle of, yeah, I think this one everyone can do on their own. Ukikwama unaweza uliza.
What does, Chris,
Yes, Ruben.
what does low income have to do with CIN?
So based on this study, yes, Richard, you can explain that further.
Low income can lead to we can classify it as under social economic factors. So this can lead to, for an individual not going to the hospital, maybe due to status of his income or high.
So that will delay maybe diagnosis.
Yeah.
All right.
Okay. So I think what about there is what Esther mentioned. Probably because there was lab testing involved. Could we be having type 1 and type 2 errors because of lab evaluation, probably? But we were told there was no. We were told there was no what chance. See, type 1 and type 2 are part of chance. Ama?
Yes, those belong to the chance.
Yeah, so that draws out that part of type 1 and type 2 because we are told there was no chance. So we can work with the confounding variable, then we try and come up with a point that will support for you to get 3 marks. Though I was thinking also recall bias can be there, because if you ask me, maybe I'm a sex worker, you ask me the number of partners that I've had, I might not be able to remember, or number of partners. I'm trying. I don't think someone can forget the number of partners.
Great. Can you scroll down?
To which part? This is the other. This is question number 3.
Yes, question number 2 up.
Apa juu? Apo? Okay.
Is there a place wamekuwa wameandika, nilikuwa tumeona wameandika.
Wameandika nini?
There? Okay, hapo tu. Okay, question B.
Question B ndio hiyo.
Hello, question B.
Yes, nakusikia.
Okay. The author felt it was notable that unlike previous research. So, unaona hiyo unlike previous research, nilikuwa naona these were 2 research that were done. And we have not been told about the kind of environment that they were being done. So maybe they were doing, one was done in different environment, and the other one was also done in a different environment. Could that affect the outcome?
Yeah, it could. So how do we put that point across? The matching, maybe the matching of, but that one is for correcting. If you use different environment for geographical area for the cases and control, that is how do we? Okay. Let me think through it before I mention it, because that is where now the issue of matching comes in.
So no, not really matching. You see, up there, the study, cervical lesion diagnosed between November 1994 and October 1997. And then for sometimes again, they The study was not done. The second study was not done immediately, Cindy.
No, there is no, this is just one study.
Yeah, no. Okay. The author felt it was notable that unlike previous research.
Yeah, the research that were done previously before 1994, probably.
Yes, so there were two research that were done before that one and this one.
Yes.
Cindy?
Yeah.
So maybe I was trying to put it in such a way that the one which was done in the previous or the earlier, that kind of environment or risk factors would have changed.
Yes,
would have changed over the time, over the period of time.
Yeah, very true.
Sindio?
Very true. That can also be a good explanation.
Yes, something like that.
That can also be a good explanation. Maybe, or even there were other confounders that played role, or other factors that played role in the previous that now are that those factors are not there during
risk factors.
Risk factors, yes.
Yeah. So let us put it
as risk
change,
factors.
maybe changing risk factors. In the previous research, the risk factors may have shifted or changed or maybe disappeared.
Yeah, it's possible.
Or they were
because
not
now,
there.
Yeah, so it's very possible. Because if you have many sexual partners and you're using protection, you're using condom. So, yeah, those things can. Okay, so any other point before we, because I don't think we need to proceed.
Can you repeat the 2 points for me so that I may capture them properly?
Now we have talked about, Richard, you can proceed.
We have talked about confounders, which we have said that there could be some other variable which could have influenced the relationship between sexual activity and CIN, which were not captured in the study. Then, changing risk factors. Since these were two studies, one was done previously before this one, which was done between 1994 and 1997. Okay.
So thank you. I think
changing risk factors.
Yes.
As the time went by.
Yes. As the time changed by.
Okay. All right.
Yeah.
Good. Any other because now with the time sidhani kama tunaweza proceed ama mko na energy tuendelee for question number 3. We can attempt it. Watu wako na energy.
We can attempt. It is only that there's a lot of literature. This guy produces a lot of literature. By the time you reach to the question, it's like you have forgotten what you have read.
Yeah, let me go through it quickly. So consider the following abstract. Oral cleft, transforming growth factor alpha gene variant, and the maternal smoking, a population-based case control study in Denmark, 1991-1994. And it is documented in the American Journal of Epidemiology. Studies in the United States have indicated that maternal first trimester smoking and infant transforming growth factor alpha, TGFA, locus mutations are associated with non-syndromic cleft lip and or palate. In a Danish case control study of CLP, the cleft lip and palate, the author studied the effect of smoking and the TGFA alleles in an ethnically homogeneous setting. Interview information was obtained for the mothers of 302 cleft palate, lip and palate cases, and for 567 mothers of non-malformed children. So these are controls, these are the cases. Multivariate logistic regression analysis revealed that smoking was associated with moderately increased risk of CLP, odds ratio of 1.40, with that confidence ratio, blah, blah, blah. TGFA genotype was not associated with cleft palate and lip. The rare TGFA allele occurred in 25% of those cases and controls, with an average of 14% in their white population. Furthermore, the frequency of cleft lip palate in Scandinavia is among the highest in the world. Hence, it is possible that the previously reported association between TGFA and cleft lip palate to some degree can be attributable to confounding by ethnicity. Question number 1. The authors conclude that the previously reported association between TGFA and cleft lip palate seen in the US was possibly caused by confounding by ethnicity. What technique did the author use to prevent confounding by ethnicity in their study? 1 mark.
Matching.
So matching. So she looked for the mothers used the ethnically homogeneous setting. Sindio? So that becomes matching automatically. Ama kuna mwenye kuna different answer? Good. As you think about that, we can go to part B. Using the confounder exposure disease drawing illustrated in class, depict how the authors pre-included confounding by ethnicity. Specifically, indicate the diagram which arm or arms are affected. Wow. So how do we draw this?
Hello.
Yes.
So we have a exposure. Then disease down there. Then confounder at the middle. See at the middle, but middle at the left.
Like, let me bring the ilikuanga lecture gani we can draw the practically.
Ngoja usilete kwanza kidogo.
Sawa, no problem.
Okay. So we should identify our exposure here. So exposure is
exposure. Ni hiyo TGIF.
Yes. So TGIF is our
TGIF
is our exposure. Then
so is ethnicity a confounder? Or is
yes,
it along the line of what do we call it?
But ethnicity is a confounder. Depicts how the authors precluded a confounding by ethnicity.
So we need to have something like this. Someone ethnicity is a confounder. Yes. Let me. I'm trying to look for ni assignment yenye hii ya mwisho yenye ametupea answer. Ametupea answers. Did I download that kweli?
Smoking iko wapi? My bado ni predictor.
Mwalimu hajashare hizo nini hizo za answer za not cut 2 na hiyo ingine. Okay, let me look for the one that we tulijaza.
Chris. Unasemaje?
Nasema I'm trying to look for that diagram so that we can draw together.
Okay.
Let me look for it quickly. Ilikuanga lecture 8. Yeah, there you go. So we want to draw something like this. Let me share the screen. We want to draw something like this, if I'm not wrong. So ndio ni kitu kama hii.
Yeah, ni kitu kama hiyo.
Okay. So we can use this one.
Niko sawa.
So amuku niambia hizi arrows inamaanisha nini? Hiyo kitu inanisumbua mpaka saa hii. Hii yenye na point hivi ni na point hivi inamaanisha nini? Hii yenye na point direct inamaanisha nini?
Yenye kuna double arrow ni non-causal.
Non-causal?
Yeah.
Meaning there is no association ama nini? So hapa ndio tutaweka ethnicity. Si ndio?
Yes.
Then tuweke hiyo TGIFA hapo. Alafu hapa tuweke cleft lip and palate CLP. So inafaa kukaa kitu kama hivi, si ndio?
I think hiyo TGFA bado it is coupled with his first trimester smoking.
So tuichore aje? Actually walikuwa nasema if I understood the nini well, walikuwa nasema venye wamesema, let me just repeat it quickly so that we understand. So go to stop sharing and share this. So you see wanasema yes. Let me just repeat it quickly. So studies in the United States have indicated that maternal first trimester smoking and infant transforming growth factor alpha, that is TGFA locus mutations, are associated with non-syndromic cleft palate and lip and palate. In Danish, hii yenye tunaongelea sasa, in Danish case control study of CLP, the author studied the effect of smoking and TGFA alleles in an ethnicity homogeneous setting. Interview information was obtained from the mothers, that is 302, who want cleft palate, lip and palate, and 567 were controls. Then motivated logistical regression analysis revealed that smoking was associated with moderately increased risk of CLP, odds ratio of 1.04. Then TGFA genotype was not associated with CLP. The rare TGFA allele occurred in 25% of both cases and controls, compared with an average of 14 in other white populations. Furthermore, the frequency of CLP in Scandinavia is among the highest in the world. Hence, it is possible that previously reported association between CLP to some degree can be attributable to confounding by ethnicity. So our risk factor is not even TGFA, is it? Or I think it is smoking.
Yes, I was saying.
Yeah, our exposure was Nini. This one is eating GFA is also a confounder. I don't know. Okay, we can think through that. So part number C, as we think through that, in this study, the authors matched controls to case based on birth of place of birth of the infant by selecting controls from the same hospital in which the case mother. So allow me to mute Benson. So in this study, the authors matched controls to cases based on place of birth of the infant by selecting controls from the same hospital in which the case mother gave birth and a calendar time, that is day and year of birth, by selecting the two most proximate normal births in the hospital in which the case mother gave birth. Can you speculate as to why place of birth and time were considered as potential confounders? Someone?
Hello, Chris.
Yes, Richard.
Wale tena umetoroka B.
Nini yo? No,
B, question B umetoroka.
Ni vile nimeuliza nikapata hakuna mtu ana respond, nikasema niendeleange because pia time imesonga, it's almost 9. But I can just go back, I have no problem. So long as we get the answer.
Ebu confounder nimekuandikia hapo.
Yeah, nimeona hiyo non-coso. The explanation that you have given kwa chat ya non-coso. So non-coso refers to non-causal relationship refers to connection between variables that do not involve one variables directly causing changes in another. Okay.
So, ulikuwa unasema kwa hiyo diagram ulikuwa unasema smoking is a confounder.
No, smoking is the exposure.
Like, so, tuweka hapo juu smoking.
Yeah.
Why?
Because we are told hapa tunaambiwa hapa, nataka tusome tu hapa kutoka hapa kwa
Is there in literature? It is stipulated.
Yeah. So they were trying to look for growth factor, alpha gene variant, and maternal smoking. So they were looking for the two. But when you look at what the study revealed is that smoking was associated with moderately increased risk of CLP, but TGFA genotype was not associated with CLP.
Yes.
Umeona? So that is why we were saying, should we put both smoking and TGFA as exposure, or we just put smoking? Because they were trying to study two things: growth factor alpha gene and maternal smoking. So should we put both as the confound as the exposure upper?
Yes.
So we say smoking, maybe, and TGFA. TGFA. Tuko sambamba mpaka hapo? Do we agree?
Yes.
Yes.
So this now will we talk about now this thing here? This arrow, should it be pointing both direction ama ni side moja? This one.
You need have arrow both sides, eh?
Yenye naangalia both sides.
Have arrow. You understand arrow?
The arrow ni gani?
Basically the top half coming down the other half on the other side.
So kukuwe na arrow mbili.
Lakini zikuwe moja inaonyesha kwenda juu na nyingine chini.
Okay. So kukuwe na arrow mbili, moja ina
Not really 2 arrows, eh? One. Let's put one.
hivyo na ingine hivi.
That is okay.
That is okay.
It is only that you indicate it is in 2 directions.
Okay. So we can have it that way. Hello.
Yes.
Okay. So we can proceed. So this is what we will that this with some small explanation, we should be able to tackle number 3B. Sindio? 3B, is it? So I was trying to read through the 3C, but naona time kumefika 9 p.m. Should we still continue ama to we pick from there tomorrow? Ati kitu na submitiwa Monday.
So tomorrow mtatumit tomorrow.
So members, what do you think? Should we stop there or we finish the two questions, the 2 parts? Then kesho
tuko number C. Ama ndi.
Number C ndio tunaenda next. So in this study, hata tukiongea hivyo tuna waste time. In this study, the authors matched controls to cases based on place of birth of the infant. That is, by selecting controls from the same hospital in which the case mother gave birth and calendar and time, day and year of the birth, by selecting the 2 most proximate normal births in the hospital in which the case mother gave birth. Can you speculate as to why place of birth and time were considered as potential confounders? Why? Place of birth. Yeah, there is a suggestion from Esther that we can leave spaces for mahali hizo bili hatujafanya so that people can come with answers tomorrow when we converge for the discussion. We want also to finish tomorrow with research methodology. So we can brush through this quickly. Then we finish up with research methodology. Remember we had started it tukaachia mahali. Hope kila mtu akona inspirations, you have gotten inspiration on how to go through the research methodology question, so that tomorrow we'll take less time to come up with a topic, research topic, then we can break down other parts. If that is agreeable, we can stop there. Because we also leo hata ni Saturday, nataka kwenda kukunywa bia mbili. So we can meet tomorrow.
Right. Good night.
Yeah. So bye. Good night, guys. Thank you for joining. See you tomorrow.